Okay.
What much of the work did you do from yesterday?
I did all of them except for 25 and 27.
So you did 3?
Yep.
I did all of them. They weren't that hard, surprisingly.
All right. I'm going to backtrack for kind of a refresher to 23.
What?
That's terrifying. We're going backwards.
So y equals
2, 3.
I thought you were
1
waiting on us to say
plus.
something. I was like, I don't know.
Y equals.
No, I was trying to figure out y equals 1 plus cosine squared of 7x cubed. So I got a chain rule and a chain rule and a chain rule.
Die.
All right, so the derivative of the whole piece would be 3 times 1 plus the cosine of squared of 7x squared. Like glitched there for a second.
You glitched. So you also have code in your brain?
What?
You said you glitched, right? You're a computer like me.
Oh, I thought you said you have COVID in your brain.
No,
That's
code.
why.
I was very
That's why I was confused. I was like, what?
No, you're not
Like
one of
what?
those primitive creatures.
I
with
was
those
like,
ears.
I haven't had it in 3 years, so I think I'm in the clear,
Guys,
but
she's
maybe.
contagious. It's in her brain. Josh is just a stipulation. It's okay.
I was just saying, like, you're not one of those primitive creatures with ears. You have code. You're advanced.
Sure. Okay, the derivative of the inside, derivative of 1 is,
I really hope no one sees this video.
well, times, or not time, well, plus, well, you know what I mean.
Yeah.
I do.
The derivative of, so I think about this as cosine of 7x squared when I do this. So this is going to be 2 times the cosine of 7x times the derivative of cosine of 7x would be minus sine of 7x times, what's the derivative of 7x?
7.
Times 7. So, when this is all said and done,
Love that.
I get negative 42 times 1 plus cosine squared of 7x squared times cosine of 7x times the sine of 7x. To appease Josh.
Oh, thank you. You know, 42 is a pretty decent number.
It's aight. Alright, find y double prime.
Oh my gosh.
30.
Wait, really quickly. How did you get the cosine of 7x times sine of 7x?
Here,
Yes.
I just multiplied these together. The negatives out front.
And just
So I did
throw it up.
3 times 2 times the negative times 7 to give me negative 42. And then I just multiplied everything else.
Okay.
Alright, what's the derivative of cotangent?
You got this, Virginia.
I know, I'm thinking. Hold on.
I'm writing down the problem. That's why you got this.
No. Yes. Negative cosecant squared x.
Yep. And I need the second derivative. So how would I find that?
Would it be
Let me just rewrite this as negative cosecant of x squared.
Yeah, if you want to think of it like this,
Would it be
you can.
negative 2 cosecant of x?
Negative 2 cosecant of x. It's a chain rule.
Oh, times, let me think of it. Negative cosecant of x, cotangent of x.
Yep. So then becomes positive, so I would get 2 cosecant squared of x times cotangent of x.
Y prime prime. So how would you write the y prime prime in the dy dx?
It's I think it's this way. It's been a while since I wrote it like that though. 'Cause I usually just write this way.
Yeah.
Because like I've seen them with like the 2 on like something. So here, let me just look in the book for an example. D squared y over dx squared.
Yeah, I was gonna say I thought there was another squared somewhere, but I couldn't remember where it went.
So y is like that.
Because this is dy dx times d dx. He's glitching. 34. Find the value of fog prime at the given value of x.
Love it when fog is prime.
F of u equals 1 minus 1 over u. U equals g of x equals 1 over 1 minus x. X equals negative 1.
I'm glad that x doesn't equal positive 1. Well, am I really? If x equals positive 1, then would we be able to solve it?
No. Be undefined.
Why couldn't it be positive 1?
Alright. I'm just going to treat this as y here just for the sake of notation. So y prime equals, what's the derivative of this?
Negative
Negative 1? No.
2, maybe negative u to the negative 2.
What happens when you take the derivative?
Positive.
Yep.
Stupid.
U to the negative 2. What is the derivative of u? Man down.
Just kicked it over. Can we rewrite that one? Yeah, I'm sure we can.
You said if it, with the derivative, the negative goes away.
Hmm?
Like if you put it out front, or just because
Well,
it's
it's
like,
multiplied by a negative, so it makes it positive.
would it be like
What's the derivative of the top
0?
times the bottom? 0. Minus the top times the derivative of the bottom. What's the derivative of the bottom? All over 1 minus x squared. Up here, this makes it positive, so u prime is 1 over 1 minus x squared. That was my shoes.
Kind of reminds me of my brain on that one calculus quiz we took.
Yeah.
I looked back on it, and I realized that, like, I was adding things the whole way through, and then when I got to the very last step, I decided, oh, I'm gonna multiply those instead of add them.
How'd you get
And I got it
the
wrong.
thing for u prime again? Like the
Quotient rule.
oh.
So now I plug in. It's glitching. I plug this in for u. Multiply by u prime. So I get 1 over 1 minus x to the negative 2 times u prime 1 over 1 minus x squared. What does this become?
Like 1 minus x squared.
Yep, 1 minus x squared
Okay, so I'm not crazy.
times 1 over 1 minus x squared equals 1. We did it.
So at least it's something equal to 1. Not the one thing is equal to 1. Or 0.
And the x value that they give you is only really relevant if we get to the end and still had an x left. Then we would plug it in to get the final number. So in this case, we didn't need it, but in some of them you will. 36. Oh boy.
That's 6 squared.
F of u equals u plus 1 over the cosine squared of u. U equals g of x, which equals pi x. X equals 1/4. So I would probably rewrite this as u plus the cosine of u to the negative 2 to make my life easier. So what's the derivative of that?
One minus 2 cosine of u to the negative 3.
Times what?
Oh, how would you get that part?
Negative
Times-
sign.
Yeah.
And what is u prime?
Pi.
Pi. All right, so now pi x is getting plugged in everywhere there's a u. So I get 1 plus, I'm multiplying these, 2 times the cosine of pi to the negative 3. Oh wait, pi x. Pi x is going in for you. Times the sine of pi x. And then that whole thing is getting multiplied by pi at the end. Because it's times the u prime part. So now's where I need to plug in for the x value, because otherwise I can't really do anything else with this. So I'm going to put in 1/4 for x. So this is going to be, I want the pi in front. I don't like pi in the back. 1 plus 2 times the cosine of pi over 4 to the negative 3 times the sine of pi over 4. What's cosine of pi over 4?
I mean, square root of 2.
Yep, so I'm just going to rewrite this way without having to redo it. What's sine of pi over 4?
Square root of 2
So now I need to move this to the bottom because this is a negative root. So pi times 1 plus 2 times 1 over the square root of, no, I'm going to do it this way. Hold on. I'm just going to flip it to make it 2 over root 2 and then cube it because that looks prettier. Times this, not sine, root 2 over 2. Because now what can I do?
Cancel out of root 2.
I mean, you could also cancel out 2.
Yeah. So what I would say is perhaps to redo this as, or like to rewrite this piece as 2 over root 2 squared times 2 over root 2. I mean, you don't actually need to rewrite it, but you know what I mean. So then that cancels. So you're just left with that piece. That's being squared. All right, so when I do that, then that's going to give me 4 over 2 times 2, so 2 and 2 cancel. So 4 plus 1 times pi is 5 pi. And it doesn't really matter how you get from point A to point B as long as you have logical work that gets you there. There's a couple different ways we could have written, like, kind of written stuff in there to get there. All right. 40. Find dy dx if y equals the sine of x squared plus 1 by writing y as a composite with, so 40, we have y equals the sine of x squared plus 1. Part A wants us to do this as a composite function where y equals the sine of u plus 1 and u is equal to x squared.
How much space do you think this is going to take?
So I have 2 lines under this, and then there's a part B with 2 lines under that.
Okay, and width-wise?
This is as far width as it's going.
Okay.
Are you struggling to write it on your piece of paper there?
Well, some of these other things took up a lot of
All right, so
In other words, yes, I'm struggling.
dy du. What's the derivative of this here?
Of what?
Let's say cosine of u plus 1.
Chain rule.
Times 1.
Yeah, times 1, so I don't need to. But I want to make sure that you're seeing, okay, this is a chain rule, so I need to be paying attention to it. And then du dx is what?
2x.
2x. So then we just multiply. So I get 2x times the cosine of, and then we got to make sure that whatever u is, we replace that here. So x squared plus 1. So this is like substitution as well as everything else. All right, b y equals the sine of u, and u equals x squared plus 1. So what is dy du?
Cosine of u times 1.
And what's du dx?
2x.
Yep. So we take that and multiply it, replace u with this stuff. So I get 2x times the cosine of x squared plus 1. What do you notice?
Thankfully, it's the same thing.
No matter how I break down my composite function, I'm going to get the exact same answer either way.
I mean, I would be concerned if it wasn't the same thing.
Yeah.
Because then I might, like, fail a test or something, if that was the case.
All right, I'm going to do these next two problems out of order. One, because 46 is shorter, and two, 46 is easier to see what's happening before we go back and do 42. And then that'll be it for this section. So 46, so these ones say to find the equation of the line tangent to the curve at the point defined by the given value of t. So 46, x is equal to 2t squared plus 3, and y equals t to the 4th, and then t equals -1.
Make sure that enough space for this one.
I used like 6 lines, but it just depends on how you.
And that's as wide as it's gonna get.
Oh, yeah.
Okay. It's more like width that I'm
Fair enough.
struggling over.
All right, so when we found like the equation of the tangents before, what did we have to do?
A lot.
Yep, we took the derivative.
Just gotta
What
remember
else did
all
we
the
have to
things.
have to find the equation? Well, yes, that's what the derivative's gonna give us. But what else do I need to be able to write my equation of my line?
A cooperative brain. A point.
A point, yes. So let's find the point first. How might I do that?
Plug in the stuff, like define my x and y, plug in -1 to t.
Yep, so if I plug in -1, what do I get for x?
1.
1.
For x?
Oh, 5.
Yeah. I saw a 3 and I cubed the 1.
It's okay, I did that.
I was so confused. I was like, what is happening?
Forgot about the negative.
Oh, I remember the negative. I just cubed the 1.
Okay, what is y?
1.
All right, so a little bit different compared to the ones that we had been doing, but since I have two separate equations here, I need to, well, there's a couple different ways I can do this, but the easy way is to take the derivative of each equation and then use the slope formula, delta y over delta x. So, what is the derivative of x? So what is dx dt?
4t.
Yep. And what is
So that's why I cubed the negative one, because I wrote t cubed.
dy dt?
4t cubed.
Yep.
Now, Ricky, you had no excuse for that. I just wrote the problem
I was
wrong.
just rushing.
I think she was looking at y.
Yeah, that's what I was doing.
All right, so slope is y over x, so this is going to be, so delta y, or delta x, in case we just need for reference. So 4t cubed over 4t. Obviously, this can cancel.
Just love it when t is in a cube.
So I'm going to end up with t squared, so negative 1 squared is 1. So this is my slope.
I love that the slope is 1.
So to write the equation, y minus 1 equals 1 times x minus 5. So y equals x minus 5 plus 1, so minus 4. So y equals x minus 4. And obviously, since the slope was 1, I didn't really need to write this 1 times this stuff, but I just did for reference. All right, now we can backtrack to the one that's harder. So we're going to be doing the same thing, but with trig functions. That's why I do this one first. I don't know why they start with trig functions and then they work their way down to the easy stuff. But nonetheless, we do that. The other thing we could have done with this one was we could have basically solved for t over here and then plugged that in here like we did. If you remember last year, we briefly did parametric equations, and we did it a little bit at the beginning of this year in the first chapter, but not a lot with it. That's another way we could have done this because it's technically a parametric equation. But it works to do it this way, so it doesn't really matter. Okay.
I'll have to get my little homework paper out. Trying to see how much space I could use on this other one.
Yeah, this one takes up a lot more space, so probably a good thing you're starting fresh.
Well, not quite fresh.
Well,
Fresh-ish.
you know what.
Should I do this part or this part?
It's wide, so probably the bottom.
Okay.
Because there's going to be a graph.
Ew. How dare you?
All right, so first thing I need to do is find our point. So I'm going to plug in negative 1/6 for t. So x equals the sine of 2 pi times negative 1/6. So basically, what is the sine of negative pi over 3?
Negative.
What is the y value right here?
Wait.
3 over 2.
How about negative root 3 over 2?
The negative that I said earlier carried over.
Negative root 3 over 2 is x.
I was just finishing my thought.
Y is the cosine of 2 pi times negative 1/6, or we can say the cosine of negative pi over 3. What is the cosine here?
negative 1/2.
Positive 1/2.
Positive 1/2.
So this is 1/2. All right, now I need to find the derivative of both pieces. So, and just to be clear, they don't put parentheses, but all this stuff would be inside the trig function. I think y'all probably knew that, but just
I don't
making
know,
sure.
I feel like I put too many parentheses in things.
dx dt. So what is the derivative of sine of 2 pi t?
Cosine of 2 pi t times 2 pi.
Yep, times 2 pi.
Almost forgot that pi was a constant.
I know. I did that too, and I was trying to.
That's why I put it on your test.
Oh yeah.
Yeah,
was
I
very
looked at
surprised
it.
I got that right.
At the beginning, I looked at it and it was like, oh no.
Yeah, y'all were like, oh no. I was like, they've got to be joking.
When you said that, glad I got
I
it
wasn't
right. I was
joking
like,
first.
thank goodness.
I wasn't joking at first, but
I
then
wasn't either.
but then later I looked at it again and it's like, oh.
Y'all had me very
That's awesome.
concerned. Like,
then, like-
very concerned.
Other answers were more concerning.
Alright, what's dy dt?
The negative sine of 2 pi t times 2 pi.
Alright, so now y over x to find my slope. Negative 2 pi sine of 2 pi t over 2 pi cosine 2 pi t. 2 pi's cancel. So negative sine of, well, that's going to end up just being pi over 3, or negative pi over 3, over cosine of pi over 3, negative pi over 3, whatever. Which we already know those values. So the sine one is negative root 3 over 2, but times a negative, so root 3 over 2 divided by, that one is 1/2. So the slope is root 3. So how do I write my equation of my line?
Y minus 1/2 is equal to root 3 times x plus root 3 over 2.
So then I get y equals root 3 times x plus 3 over 2 plus 1/2. So y equals root 3x plus 2.
That one wasn't too bad.
No, it's just longer.
No.
That's why I like to start with the other one. All right, what was the last problem I gave y'all?
27.
27. Okay. So if you feel like you need to do another one like we were doing from yesterday's review, 21, but you don't have to do that one. 29, 33, 39, 41, and 45.
You could say like we're gonna have more after this.
What do you mean?
Like, we're gonna do more examples.
This is it. I wasn't sure if we would get through it all today.
No.
Hence why I said probably.
So do we need 4.23 now?
Yeah, because I'll probably, here's what I'll do. I'll give y'all like probably 20 minutes at the beginning tomorrow to work on this, but then we'll like start the next section probably at like, I'll just say at like 1, or well, never mind, tomorrow's chapel day. At like, let's see, this would start at like 12:55, so like 1:20. That would give us like 20 minutes into the next section. The next section's not really hard, it's just a little different, so. Anyways. Ooh, my iPad's on.